Here are two AI voice agents. Same question, same underlying intelligence. One feels like talking to a machine, the other feels human. And here's the surprising part. The difference usually has nothing to do with how smart the model is. Because voice agents don't fail because they're wrong. They fail because they're slow. Today, we're opening up the hidden architecture that makes a voice agent feel alive. First, let's kill a misconception. A voice agent is not just a chatbot with a microphone bolted on. It's a real-time system that listens, interprets, and responds as the conversation happens. It understands context, follows instructions, and keeps a human in the loop. That's what powers the AI you talk to in support, healthcare, sales, and smart devices. But to pull that off in real time, you need an architecture. And there are two ways to build it. Option 1, speech-to-speech, also called end-to-end. Audio goes in, audio comes out, one model, no visible text in between. Because there's just one component, it can be incredibly fast and feel supernatural. Fewer moving parts, lower delay. But there's a catch. It's a black box, hard to debug, limited control over the reasoning, and tricky to plug in tools or memory. So it's great for simple stuff. Assistive devices, basic conversational agents, on-device gadgets where speed beats complexity. Option 2, the pipeline approach. And this is the one almost every real, scalable voice agent actually uses. Instead of one black box, you chain together separate, swappable stages. Audio comes in, gets converted to text. The text goes to a language model that thinks and decides. The response gets turned back into speech, and out comes audio. Because each piece is independent, you get full control. You can debug it, observe it, add tools and memory, and swap any component without rebuilding everything. The trade-off: more moving parts means more engineering effort, and if you're not careful, more latency. But for AI interviewers, customer support, enterprise systems, where control and reliability matter, pipeline wins. So let's open up that pipeline piece by piece. Stage 1, speech-to-text. You'll see it written as STT, but we just say it in full, speech-to-text. It turns your raw audio into words. But here's what actually matters in production: streaming. A good speech-to-text doesn't wait for you to finish your sentence. It transcribes as you speak, word by word in real time. Why does that matter so much? Because it lets the system start thinking before you've even finished talking. That single trick slashes the delay the user feels. Tools here: things like Assembly, AI, or DeepGram. Stage 2, the brain. The large language model, or LLM, this is the reasoning engine. It figures out what you actually want, manages the back and forth, makes decisions, and calls external tools, like checking a booking system or looking up your account. Here you make big design choices. Does it remember past turns or start fresh each time? Does it use a memory layer or just the prompt? Structured tool calls or free-form text? But one rule really stands out. The language model should focus on deciding what to say, not on managing audio timing. Keep those jobs separate. Tools here: GPT models, Claude. Stage 3, text-to-speech. Written TTS, but again we say it in full, text-to-speech. It turns the response back into a voice. And just like speech-to-text, the magic word is streaming. A great text-to-speech starts speaking the first words before the whole answer has even finished generating. You want natural rhythm and a consistent voice. Get it right, and the agent feels like it's responding instantly, even while it's still finishing its thought. Tools here: 11 Labs, Cartesia. So that's the core three. But they're not what makes a voice agent feel human. These next two are. First, voice activity detection. We don't spell this one out, we say it as a single word. VAD like bad. Its job, figure out when someone is actually speaking versus just silence. But it does three crucial things. It ignores dead air. It saves money by not transcribing silence. And most importantly, it detects when you interrupt. That's called bargain. It's why you can cut the agent off mid-sentence and it actually stops, like a real person would. But VAD has a blind spot. A pause isn't always the end. Picture someone saying, I want to book a flight to Berlin. There's a gap after a. A dumb system hears that silence and barges in. Awkward. That's where end-of-utterance detection comes in, written EOU, and we say the letters, EOU. It doesn't just ask, did they stop making sound? It asks, did they finish their thought? It uses pause timing, the actual words you said, and even AI prediction to decide. Do I wait or do I respond? Nail this and turn-taking feels natural. Get it wrong, and the agent feels like that person who always interrupts you. Now, all this audio has to physically travel between the user's device and your server. That's the transport layer, and you've basically got two choices. WebSockets built on TCP simple, widely supported, easy to start with, great for prototypes. But higher latency, and you handle audio quirks like echo yourself. Or WebRTC, built on UDP ultra-low latency, built-in echo cancellation, native audio streaming. It's more complex to set up, but it's built for exactly this. Let me put it bluntly. If latency matters, and for real-time conversation it always does, WebRTC isn't optional. So you've got all the pieces. What separates a great voice agent from a frustrating one? 6 things. 1. Latency is everything. Every component must stream, be cancelable, and run asynchronously. Speed is the feature. 2. Interruption handling. When the user cuts in, the agent must stop talking instantly, cancel what it was generating, and start listening again. 3. Session and state. It has to remember the conversation, track what tools it's used, and clean up after itself, usually with session IDs and fast in-memory stores like Redis. 4. Observability. If you can't see inside it, you can't debug it. Log the audio, the transcripts, the model's inputs and outputs, and the latency at every stage. 5. Cost control. Voice stacks up costs across speech-to-text minutes, LLM tokens, and text-to-speech audio. Trim it with silence filtering, smaller routing models, and caching. 6. Safety and trust. Voice feels personal, more intimate than text. So restrict what tools it can touch, guard against hallucinations, and handle silence and confusion gracefully. So let's zoom back out. A voice agent isn't just a smart model. It's a real-time system where timing matters as much as intelligence. The best ones stream instead of waiting. They know when to listen and when to speak. They match the rhythm of a real conversation, and they fail gracefully. They're judged not on how accurate they are, but on how fast and natural they feel. That's the hidden architecture behind every voice agent you've ever talked to. Subscribe for more AI engineering, broken down visually, and tell me in the comments which voice agent you've used that actually felt human.